Awesome. Thank you so much, Aditi. And hello, everyone. I'm super thrilled to be here and to be talking to you today about AI ethics. So let me pull up the presentation that I have prepared. One moment, please. Okay, perfect. So welcome to this workshop on AI ethics. And I wanted to first start with a little introduction about me before I dive into the details here. And I also wanted to provide a little bit of details about the workshop itself and how I would be interested in structuring it. So my name is Cheruvu. I'm an AI ethics lead architect at Intel's Internet of Things engineering group. I'm also 17 years old. I've had an amazing journey so far working with a lot of experienced colleagues in the AI space and being able to assimilate those learnings and be able to contribute in the space. So I'm super excited to be here with you all to share the learnings that I've gathered over time and some very interesting concepts and techniques that are upcoming in the AI space. I do want to make a quick note that the opinions expressed in this talk are my own. AI ethics is such a broad field and there are so many different ways of approaching it. And I wanted to share what I feel is the best way forward, but of course not reflective of any particular company, industry, etc. And with that, I wanted to provide a few quick details about the workshop itself. Please feel free to interrupt me at any time with questions. I'm planning to make this really interactive, so would definitely appreciate your feedback and input via chat, or please raise your hand or just interrupt me while I'm speaking. And in terms of the agenda that I had for today, I did want to start with a quick challenge related to AI and get your thoughts first. So beginning with this, let's start with a quick exercise. And this is actually a little bit of a challenge because I haven't yet defined what AI is. So I'm relying on you to think about the last time you've heard or seen artificial intelligence defined, whether that be as, this agent Siri or Alexa that's taking your words and translating it into commands, or different types of technologies. And with that, I'm going to leave that in suspense and ask you to find an object around you that is influenced by AI. And I'll provide an example here. So I've got my notebook. And here, as part of this, one of the key things that we're seeing that AI is starting to bring out is automatic note-taking, where you're able to essentially write down your notes and then it's able to upload them to Google Drive or similar. We're also seeing some apps that are coming out where you're writing down math equations and they're transcribing it and then essentially doing the calculations for you and returning the result. So that's an example of an object around me that I'm seeing influenced by AI. Now I wanted to make it your turn, so show us via camera an object that you see that's influenced by AI, or describe it via 1 to 2 words in the chat. And the challenge starts now. So looking forward to hearing what you'll come up with. And I'll navigate to the chat pane. Okay, so we have one point on Google Home that takes some words that appears as advertisements on social media or platforms. We've got a HomePod or iPhone using Siri's voice assistant, your phone, which is actually an awesome suggestion. So thank you for bringing that up because it has so many different instances and uses of AI. And then we also have my computer, same thing there from Microsoft Word, Google Slides, a bunch of different applications on your computer that are using AI, including Cortana as a voice assistant and similar. Awesome. Okay, so given that, I'm going to go ahead and move on to the next part where I'm actually going to define now what is AI. So interestingly, a lot of the thoughts that we have around AI are really around voice assistants, where we're essentially having these systems that are able to understand our voice and are able to provide some commands. And similar, what I'm seeing in the chat as well, we're also seeing that a lot of these are centered around speech recognition and similar. Now, interestingly, if we take that a step back and figure out what is the core part of that technology, what do we really mean by artificial intelligence, I wanted to provide 3 definitions to you all that I think is a very interesting way of looking at this. So the first is AI, the Wikipedia definition, in terms of intelligence demonstrated by machines, as opposed to natural intelligence displayed by humans or animals. Now, this is kind of high level. Wikipedia go into a lot more detail regarding this, but we talk about intelligence. What do we really mean? And throughout this presentation, I want to probe that a little bit, start to think about how we look at intelligence as humans, and then how artificial intelligence or algorithms are looking at this as well. And I think the first step towards that is doing a much more detailed definition that we can start to use in this conversation. And with that, I want to introduce the EU Commission's Communication on AI, which are some of the policies in AI around this space. We'll touch on what exactly I mean by this in a moment. That is actually very clearly defining AI for the use of regulations of these technologies. So here, the definition that they're providing is systems that can display intelligent behavior. But how do they do this? They're able to analyze their environment. In the case of Siri, Cortana, Alexa, etc., they're really able to understand your voice, figure out some details, apart the speaker from some background noise. And some of you may have noticed this when you're saying something like Sir or Alex, when you're kind of hyphenating the name of the voice assistant, they catch on to the right instances most of the time, but they completely ignore you in cases where their name is not pronounced correctly, etc. And that's really what we're thinking about here in terms of AI, taking a look at its environment and thinking, what to do next. And that's the second point on taking actions. Now, if we were to have a conversation and I was telling you about a fun fact or something similar, you would be reacting to that or responding to that in a certain way. Maybe you'd be sharing another fact or something similar. And with that, we also think that intelligence is really about reacting or responding to your environment. And I think this is super interesting and important because a lot of these algorithms that we're seeing today, and when I say algorithms, you can think of this as essentially, a human mind, but kind of artificial, where we don't have a human behind it. They do a lot of information absorption. So they're taking up a lot of information about their environment. They're looking at a bunch of images you're feeding it. They're hearing your voice. They're essentially trying to pull as much data as they can from their environment. But the key thing that AI is all about is also acting on that data. And again, with that speech recognition algorithm, it may be just reacting back and taking part in the conversation. With a self-driving car, it's actually driving the car. So a lot of different ways that AI can take in a lot of information and then also start to act based on it. And if some of this doesn't make sense, I'm going to be talking about this a lot during the course of this presentation, so stay tuned. Now, with this, I want to bring forth the third definition. And this is, I think, the most loaded definition that I've seen so far with AI, but it does an excellent job of covering the entire idea that we have with AI. And that's the following: big data driven, machine learning, algorithm centric, complex socio-technical systems powered by supercomputing. So I wanted to go into each of these words because, again, it's kind of a loaded sentence, but it has so much information in it that I think this audience would love to hear more about. So with that, I wanted to start with big data. What do we mean by big data? It's essentially data that's big. We're seeing a lot of different data sources popping up. And I want you to, again, take a step back and start to think about some ways that you could pull data from your own life, whether that be, the time that you wake up, what you do right after, when you're having breakfast, when you're logging onto your computer, who you're sending emails to, your school routine or work routine, or something similar. All of these are data points, including the types of products that you're purchasing or shopping for, the clothes that you're wearing, etc. So now if we start to think about personal assistance or AI that's designed, and start to see there's a very simple point here. The more that AI has access to this type of data about our trends and behaviors, then the easier and more helpful it will be for it to provide us with, some helpful recommendations. For example, if I'm shopping for a product and I want to be able to figure out products just like these without having to do a lot of effort combing through all of this, then AI can provide us with, hey, this product looks similar to what you're looking for. Maybe you should go and look at it. And at this point, a lot of you may be thinking about Netflix or Amazon. That's exactly what I'm talking about here. AI is powering these conglomerates and these essentially shopping companies or distribution stores or similar, and being able to provide some helpful recommendations based on what we are looking at and analyzing our trends. Now, given that, let's go on to the second part of this in terms of machine learning algorithm centric. So what does this mean? AI is actually, I would say, almost a completely false term. It's actually somewhat of a myth. And why do I say this? And why is this title also, artificial intelligence ethics? So the interesting thing here is that artificial intelligence does not exist today. We don't have even, I'd say, a really good attempt at having agents that are able to perform just like humans. I'll give you an example of this. Again, some of you may have heard that there are a couple of AI algorithms or essentially AI bots that are able to play role-playing games, defeat humans at checkers and chess, etc. But today, AI doesn't have the skills to stack blocks on a table, something that a one-year-old could do. It's a really big challenge in the field, but it also shows how dumb these agents really are. So when we're talking about artificial intelligence, I wanted to share with this audience that if you've heard this before and seeing a lot of the concerns and everything tied around it, one of the key points to understand here would be that artificial intelligence is still very dumb. They're working on ways to improve this further, but the key thing here is that the reason why it's dumb is that it boils down to a very simple philosophy. Whatever data that you're giving it, again, it's just going to analyze that, figure out, okay, so this is the data you're giving me, and you're also giving me some outputs. For example, I'm going to give it a picture of a cat, and I'm going to tell it it's a cat. And what the algorithm is going to do is it's going to take that image, take the cat, and then form an internal representation of it. Now, if I were to show you an image of a unicorn or something similar that you hadn't seen before, you'd do something similar because I'd be giving you the image, I'd be telling you this is a unicorn, and then you'd learn about it. Now, what's the interesting thing about humans and why are we so awesome compared to AI? If I showed you one image of a unicorn and then I told you this was a unicorn, and then I let you go and I showed you a bunch of images of horses and unicorns, you'd be able to do an awesome job with figuring out which ones are the horses versus the unicorns. Now, if you give that same task to AI, it will perform absolutely horribly. You can do a lot of things to make it seem better, but it is really hard to mimic the awesome natural capabilities that we humans have in being able to generalize information, which is the term used here for being able to figure out, okay, given that one picture of a unicorn I saw, I can now detect all of these different unicorns in different lightings, different backgrounds, etc. And that's kind of the core behind machine learning. It's really that AI algorithm, agent, robot, you can think about it in any way. It's really that AI agent being able to learn the representation based off of some inputs that you're giving it, and then be able to connect that back to the outputs. But again, we're seeing a lot of trade-offs with it being able to achieve human intelligence. Now I wanted to go to the next one, complex socio-technical systems. I think this is the most important part of dissecting AI, which is that the whole point in AI isn't that it's just awesome, it has a bunch of applications, but that it's impacting you and me. And this is really that part where we're starting to think about societal implications of technology. So hold any thoughts that you've got on that point. We'll revisit that in a moment in much more detail. But finally, I wanted to talk about supercomputing. And this is a really umbrella word, but I wanted to share an example how this might be relevant. Again, if you're using your phone or your laptop, you may notice that it heats up after a while of using it. This is exactly what we're seeing, but being multiplied by the use of AI. We're seeing a lot of really bad consequences of using AI as part of our devices. Now, of course, that's not our fault. The fault is really on the people who are developing these algorithms and also the regulators and policymakers who really need to define some clear guidelines around how do we design AI in order to make sure there are no environmental consequences. And I'm going to be talking about that as well during the later half of this presentation. So what's my goal with this workshop moving forward would be to essentially make you all experts in AI ethics, both from a perspective of somebody who may be developing AI in the future, which would be fantastic, or as someone who is going to be impacted by AI, which is all of us. When we see these agents or these bots mining our trends and trying to figure out patterns, or also from the perspective of advocates, where we really strongly feel that something needs to be done in order to change the use of these technologies. And we're able to educate ourselves about this and influence policy and the design of these systems. And these are all things that we can do today. And I'm going to share how at the last part of this presentation. And with that, let's get started. So I've been talking a lot about machine learning, some applications, etc. And now this is kind of my response to that challenge one in terms of some applications of machine learning that we're seeing. So you may see some of these as part of daily life. Speech recognition, we already talked about. Automatic language translation, if you're using Google Translate or similar, you've definitely seen this. We're also seeing a couple of other interesting things. For example, self-driving cars. And again, if you're not familiar, this would be the idea that the person is no longer handling the driving wheel. So the car would be fully handling all of the things that's really needed for a car to drive on the road. But as some of you may be aware, there is always the opportunity for the human to take control back again, especially with the technology that we have today, which is not that great. It's doing good, but not that reliable for us to be able to say, okay, now AI, you can take full control of this car. I don't need to worry about anything. We're definitely not at that point yet. But a couple of other very interesting applications, medical diagnosis. If we can train AI in this way, and now you can start to think of it as a really cool pet, where you're essentially giving it some information. You're saying, hey, at this particular time, I'm going to feed you. And then the AI agent is able to now learn that and be able to understand further. You could use that type of information in order to make it help you with medical diagnosis or similar. And with this, what can be done is you feed it images of ultrasound or similar or x-rays, and it's able to then figure out based off of that some important information like where a tumor is located or similar. We also have a couple of other ones like stock market trading, online fraud detection. So if you ever received a spam email and you're super happy that Gmail or Outlook or the email provider service you're using is automatically just putting that in the junk or the spam bin, then AI is going to start powering those. Either it is already powering these services, depending again on the service you're looking into, or it's going to start heavily influencing that spam detection and categorization process very soon. So these are a couple of the different applications of AI that don't seem apparent, but they're there. I also mentioned Microsoft Word. Whenever you're typing, if you're getting sentence suggestions or if you're using Grammarly, these are also powered by some form of AI. Even Teams, the background, I'm sure that they're actually using AI in order to be able to form this perfect silhouette with the background. So it's everywhere and so many different forms and ways. But the core idea of AI is again the same. It's like training a pet where you're giving it some input, you're telling it what to do, and then after a while, you let it go and try to see if it learned the right thing or if you have to go back and teach it. So this agenda came in a bit late, but now I'm going to dive into what is AI ethics with 4 more challenges along the way, just to get you thinking about these topics, and then actions we can take, as I mentioned at the end. So I'm talking a lot about AI, and this is a hackathon, so I wanted to bring in some code to be able to say, AI is not as blobby as we think it is, where it's just out there and we essentially don't have any control over it. I wanted to boil it down and bring it back to the code because that's always exciting to look at. And we can start to see what exactly is going on with AI. What do people mean when they're implementing AI, when we've got voice recognition assistants? What's really behind them? And at the core of this, what a lot of people mean by AI is deep learning. And this is why I say that AI is a myth, because deep learning is not the entirety of AI. There are so many different things that we need to think about to create artificial intelligence, including neuroscience, psychology, and a lot of other concepts outside of computer science. But nevertheless, if we start to look at deep learning as the primary face of artificial intelligence, what does that mean? So deep learning is kind of a subset of the machine learning space I shared earlier. So we're still training this algorithm or this code block in order to learn some sort of representation. but it is part of the overall superset of artificial intelligence. So what does deep learning look like really in code? So at the right, you can see here, we've got an example neural network, and neural networks and deep learnings are just the same terminology. And I'd like you to think about either a sandwich or a bed while you're looking at this snippet of code. And the similarity between all three of these things is layers. So the cool thing with deep learning is that as you're continuing to learn representations, what these algorithms are able to do is they learn information through a series of layers. That's how they're constructed. You can also think of it as a tunnel, for example, where you've got different components that are leading one to the other. So with this sandwich or bed, you've got essentially layers that are topping one another. And with this particular example, this is a very simple deep neural network where we've got an input layer that's essentially taking, let's say, an image or something similar as input, just in a format that the code can understand. I'm doing this at a very high level, but return back to the details in a moment. Next, we have a set of a couple of layers in order to digest and understand the image further. These include convolutional layers, which are here termed conv2D, and max pooling layers. I'm not going to go into the details of exactly what these layers mean, but at a very high level, what we're looking at here, and this is more of a detailed description, that we have our image and we've got layers of that neural network focusing on particular portions of it and being able to process it in a way, again, so that the code, or in other words, algorithm can understand. Now, finally, as we've got these conv2D and max pooling layers, we've also got flatten. Flatten is, again, very similar to, you can think of it as pre-processing if you've seen this. And we do something similar with the human brain when light is hitting our retina and we're also starting to process a lot of images. We have some processing that's taking place within our brain as well. Now, is this code reflective of the processing taking place in our brains? No, definitely not. You'll see a couple of people put images of brains, etc. when they're talking about AI. If we're looking at dealing as the face of AI, we are not yet close to having this mimic the human brain. There's a lot of interesting research in the space that's trying to figure out, okay, so how close are we really, or how far are we to getting deep learning to act like the human brain? And if there's any interest from anyone, please reach out to me and I can provide some very interesting research that was done here. But finally, in addition to flatten, we've also got these two layers, dropout and dense. Now, again, for the purposes of this presentation, the details that I'll share here are the following. So with dropout, we are essentially handling the machine learning algorithm in a way that allows it to prevent from making a lot of mistakes. For example, maybe in that horse or unicorn example, it's really doing fantastic on the examples it's showing you. You're really surprised. It's doing fantastic on, being able to detect a bunch of different unicorns from horses. But as soon as you're showing it a unicorn in like a stable or another environment or on the beach, it's doing horribly. So all of the examples that you gave it in the first round were all of unicorns, standing in the grass or something similar. But now that the unicorn's standing on the beach, it's really doing horribly in order to transfer that representation over. So functionality like dropout and similar can help with this. And this is a machine learning term known as regularization. For the purposes of this discussion, just take it as a pinch of salt, but just something interesting to share here. And finally, we've got this dense layer. So you can consider this to be the last layer of the sandwich or the bed that's recording clarification, where you're taking all of the processing that was done and now finally making it into a way that we can understand. So the first, or all of the layers of the neural network almost, are trying to process the inputs, whether that's an image, an audio sample, or a bunch of other types of data like LiDAR or radar for self-driving cars. It's able to take all of that information and process it in a way it understands. But this last layer is really crucial for processing it in a way that we understand. So what isn't shown here, and what I'd like you to imagine, is kind of a block diagram. And I'm going to revisit this right now. So what we've got here again is we've got an input image, and then we've got our neural network model in the middle. And with this last layer, what it's able to do is it's able to tell us, given an image of a horse or a unicorn, okay, this is a horse, and this is the probability, or in other words, the amount with which I'm certain that this is a unicorn. And for example, if I were to say something like, I'm 90% sure this is a horse and 10% sure that this is a unicorn, then with that, I'd be able to say, okay, so in this case, the AI is correct. This really is a horse. And with that case, it's really confident that this is a horse and not a unicorn. So I can maybe trust this AI. But let's say it's doing horribly. Maybe it was supposed to predict unicorn and instead it's predicting horse, and it's really confident that it's a horse. And if that's the case, then I'd probably be like, okay, it looks like it's really confident about the wrong thing. Maybe I shouldn't trust this. And when it comes to trust, that's what we're getting at with AI ethics. And now I'm going to take a complete pivot, use this segue, and dive into the field of AI ethics. So, what is AI ethics when we're talking about this? Is it just ethical considerations for AI, or is it something else? And now, what I wanted to share here is the following. So, I've got a picture on the slide here that has two perspectives. We've got the perspective of the public, which is us, and the people who are getting impacted by this technology. And we've got the perspective of the practitioners, the people who are going out developing these AI techniques, AI models, AI algorithms, all mean the same thing in the context of AI. Now here, let's start with the first one. So we're seeing a lot of technology in this space that really is around reading minds, where it's able to predict what you want before you've even asked for it. Think about Netflix or Amazon when you're really trying to search for something, and then it starts popping up everywhere. You're seeing ads about it, and you feel like, is this reading my mind? It's being able to predict what I want before I even asked for it, or something similar. Now, from the practitioner's perspective, the corollary here is prediction. We're developing these AI algorithms. We're not looking at this from the public perspective. Okay, users might actually feel creeped out by this because they're seeing ads everywhere popping up related to their initial search, but they're looking at it in terms of prediction, which is just how well can I get my AI algorithm or my AI model to help the user. And I'm overgeneralizing here. There are some people who really want to use this technology maliciously. That's horrible. But as a large population, I see a large part of the developers really want to make their technology helpful to the user and anticipate what we need before we even ask for it. But how is this seen in the public's eye? Definitely a lot differently. Same thing with collecting massive amounts of data. I described what big data was before, and it sounded excellent because we just have a bunch of data that AI can draw from to, again, be more helpful for us. But we're looking at this from the public's perspective. As we're starting to see the uses of this technology, we're starting to see that it's like collecting mass amounts of data. Does it have our consent? These are all critical AI ethics problems. And here, if you may see, I've got this picture of an Amazon Go store. And for those who may not be familiar, this store was essentially designed for shoppers to go in, pluck items off of the shelf, and then essentially exit, where they could do a self-checkout via AI in their phone. And with this, they're really collecting mass amounts of data as part of that story. They've got cameras everywhere, they're trying to track people, etc. So what does this mean, and what are the implications in the public's perspective? Similarly, we're talking about voice assistants. Some of you may be aware, I believe it's Google Duplex, that there are some technologies out there that can essentially mimic humans. Either they're speaking like humans, which we're already seeing with Siri and Alexa, they're able to hold a conversation in certain cases, or they're also literally, in the case of Google Duplex, calling people and scheduling appointments for you, or something similar. And with that, what does the practitioner think about this? They're really thinking about generalization. It's that word again, where we were talking about the horses and the unicorns, where it's able to figure out, just based off of a few images of unicorns, what the unicorn versus the horse will look like in a bunch of other different scenarios. So that's what they're seeing here. If I'm able to learn more about your voice and similar, and I'm able to now simulate it on my end, and AI is able to create its own voice and use it in a bunch of different use cases, then AI developers are really happy because their model isn't just a one-trick pony. It can be used for a bunch of different use cases beyond what they designed it for. Now, in certain cases, this is extremely alarming. We want to be sure that we're very careful about how our AI model is being used. But in other cases, we're quite happy because then we don't have to keep building AI models for every single task. So imagine, for example, that for every command that you were issuing to your voice assistant, or when you're using your phone or your computer, there was an AI model for each one of those commands. Now, already our phone heats up a lot after a couple of hours of use, but if we were having a model every command that we issued, that would be really, really compute intensive. We'd need more than a supercomputer to support that. So AI models being able to work for a bunch of different tasks at once is interesting and again, makes developers happy. So now I wanted to also dive into the headlines, and I think this is what I'd like to bring this audience's attention to in terms of what really is AI ethics. We talked about this in terms of the public and the practitioner's perspective. What are the critical problems that are upcoming in this space? So a lot of the concerns today in AI are all about facial recognition, and we've all seen some form of this. I can pretty much make that assumption strongly. And the reason why I say this is that, you've encountered a digital surveillance camera, and in some cases, despite not necessarily doing anything wrong, there's always this concern of, we're being watched, and then something is tracking or detecting our trends. Now, for the cases of, digital surveillance where we're really trying to protect the people who need protection, that would be fantastic. But in the cases where this technology is being exploited or abused, that is horrible. And as part of this, we have a couple of different companies out there that are really facing a lot of backlash for trying to abuse this technology in the eye of the public and the media. So an example of this is, for example, Clearview.ai, where they got a bunch of privacy complaints for a facial recognition technology that they've developed, which is scouring a bunch of data from people, Flickr and similar, and just leveraging them. And the thing is, do you have the consent? What are you using that information for? A lot of questions coming out of this. This is all in the AI ethics domain. Similarly, I wanted to bring your attention to some pretty scary attacks that happened in very recently, I'd say a couple months ago or so, where one of the first ones was around this massive camera hack through cameras that were supplied by this company called Verkada, that was essentially showing the dangers of surveillance. So what's going on here? There were essentially some cameras that were being placed in certain environments, and these attackers were able to go in, hack the camera, and start to stream over the feeds that were coming out of that without the consent of the people who were being recorded or surveyed. So that's pretty bad. We also had a very similar thing with ADT Pulse, which is a camera, like a company that's very much trusted. And in this case, there was a technician who was able to hack hundreds of customer security cameras and access very sensitive data. So with that, this really needs improvements. We need ways to be able to fight this. Now, with these 2 points, you may be wondering, how was AI used? This seems more like a hacker just going in, hacking a camera, and then figuring out the data. It's a great question. I'm not sure the extent to which AI was used as part of these attacks or was exploited or abused as part of these attacks. But what we're seeing is that AI is only going to amplify the problems with digital surveillance and facial recognition. And with that, we're seeing now a lot of outreach on banning facial recognition altogether in publicly accessible spaces. For example, we are seeing something similar done by privacy regulators in Europe. Now, I'm not going to speak to whether or not it's a good idea to ban facial recognition or not. This is really dependent on the types of issues that are coming out and what we can do about it and how we feel about it as well. But I did want to turn your attention to a couple of other key points. So I talked about how your phone or your laptop could heat up with a lot of use of AI and also the environmental consequences of AI. So one of the interesting statistics that I wanted to provide to you all would be that training a single AI model can emit as much carbon as 5 cars in their lifetime. And we're going to dive into a couple more statistics around this, but that's really bad. So as part of AI, I'm hoping that you're starting to see that we have the use cases of AI where they're applied for like facial recognition or similar. We also have the design of AI that can be problematic, allowing for like really large carbon footprint, et cetera. And finally, we also have this added perspective of regulation. So this is the positive, optimistic angle. We have a lot of amazing people who are working on defining regulations and amazing standards bodies and similar, who are working on defining regulations to make sure AI is used responsibly and correctly. And with that, now the question is starting to come in, okay, so I'm talking a lot about AI ethics, but what is the relationship to power dynamics? And this is the key point that I wanted to talk to you all about today, which is around how right now I'm talking about the design of AI systems and the application, but really all of this is powered by the humans behind the system, because we saw that deep learning snippet of code. That's really what we're talking about when we talk about AI models. Input to that block the outputs are really what matter, and who's providing the inputs, the humans behind the technology. So really, AI ethics is not just about the design of the systems, but also about the power dynamics that are being imposed by certain groups in order to exploit others. And we really want to be able to mitigate these, both societally, if we can form some sort of guidelines, regulations, et cetera, to hinder the use of AI in this way, and also if it makes sense technologically, where we're actually having some mechanisms to detect this type of thing and prevent it. Okay, perfect. So now next, I wanted to talk about some concrete examples, and then we're going to take a quick break and like with a quick challenge. So here, I wanted to share some of the key points in AI ethics. Now, if you're really interested in this field and want to make a break into it, either in AI or AI ethics, these are the things that you're going to see as super common. And it's always great to have this type of knowledge before pursuing a career in data science, machine learning, et cetera, because now this is one of the biggest concerns in this domain today. And what is that? So if I can direct your attention to the left of the slide here, here what's going on is some images of predictions that are being made by researchers of this project called Gender Shades. So to summarize this here, the classifiers, or in other words, AI models, that's again another word for AI models, were built to identify gender from an image. Already you can start to see that's really problematic because I don't just want to consider binary or female because that is just not accepting of the reality. So as part of this, though, with the design of AI algorithms, a lot of the developers just approach it this way, and that's incorrect. So that really brings up the question, are we even using that data, and why should it matter as part of the analysis, especially for applications like interactive kiosks or similar? Why do you need that information? So putting that aside for a moment, if we just assume that, okay, there really is an application that needs this type of information, and that's a flawed argument, but we'll get back to that in a moment, we're seeing that these types of AI models are actually performing worse on darker faces compared to lighter ones. Why is this? There are a couple of different reasons for this. The main reason for this, like the number one thing, is that the data or the inputs that were provided to that AI algorithm just weren't diverse enough. They were not including images of people with darker faces and were not representative of that part of the population. And the AI developers either were not noticing that or ignored it altogether. And the latter happens a lot more times than we think today. So this is a really big problem. And one of the ways that we solve this is, of course, increasing the training data set, make it more diverse, et cetera. But the other thing is we start to figure out, okay, again, but going back to that flawed argument, do we really need that data about gender? And why are we isolating it to two categories in that space? Who are the social scientists or similar and the regulators who are actually governing the use of this technology so that we're not making stupid mistakes like that during the design of the algorithms? And those are all big questions. Again, the optimistic perspective is we're working towards a good future where we're able to either ban altogether the use of these types of arguments, or we're able to essentially figure out some sort of solution. And with that, the next thing that I wanted to share was around words. So this is going back to the speech recognition agents and similar. And I know it's a little bit hard to see on the slide here, but what I wanted to talk about was essentially the types of biases that we're seeing that are creeping into these speech recognition systems. So one of the key things here, and I'll definitely share the slides offline if you're interested in looking into this, but this plot here is showing a bunch of words on an axis. And it's trying to say, okay, what words are related to each other? So for example, car would be related to Porsche or something similar. So here with this, what has been done is that there have been a bunch of words that have been outlined related to old versus young in these categories. And so as part of this, and what's not really visible as part of this diagram is that you see a lot of different biases related to old versus young folks. For example, for the young category, you might see something like sufficient or something similar. Whereas for the old category, you might see something like, let's see here, accident or something similar. So we're seeing some biases that are being reflected as part of this. And this is not really reflective of the true reality at all times. Similarly, we're seeing this apply for gender as well. There's a very common and popular example in this space on how doctor is to man, whereas nurse is to woman. And AI is starting to make a lot of these assumptions because of a lack of detailed training data, or in other words, that inputs that are being provided to the algorithm. And this is the really big problem. The next application I wanted to talk about was recidivism and AI being used to predict future criminals. And here it's biased against certain populations, and this particular article was released a couple of years ago or so. There have been a lot more research studies that are showing that for these high-risk use cases where governments and state officials and similar are trying to essentially endorse this technology and apply it for prediction of recidivism and similar, it's really flawed, the core technology behind this. So we need to work towards improvements on this and figure out societal and technological solutions that can apply for this. A lot of emphasis on the societal component because there's only so much we can do with technology. But I just wanted to share a quick description of that use case for you all. Okay, and given that, I wanted to do the second challenge here. So in one sentence, if you could share this via the chat, what do you think is the biggest ethical concern for AI? We've talked about a couple, and I'll give you an example. I think one of the biggest ethical concerns for AI today is that I just don't understand how it works. And especially the users that are being impacted by this technology don't understand it either. So because it's such a essentially block of code, you're not really sure what's going on inside of it. How is it learning those representations I mentioned, et cetera? I really want to be able to learn more about this type of technology, what it's doing, why it's making a decision, et cetera. And that's what I think is the biggest ethical concern for AI. So what are your thoughts on that? Please share them via the chat. Okay, so we have a great point. With ignorance comes fear. Any thoughts on ethical concerns for AI? Okay, we've got a couple in the chat here. So the bias that bleeds from creators of AI would reinforce the societal oppression. Exactly. This is one of the crucial parts of AI ethics, and this is often termed as fairness. And we'll look into this a little bit more, again, from a very high level from what I can present during this workshop, but you're exactly on point, Haley. And we've also got one of the biggest ethical issues for AI today is the use of AI to profit, despite possibly affecting one's mental health. Awesome recommendation here that's being proposed because mental health is going back to the societal implications and also the user or the impact to us as well. And how do we influence the technology in a way that best agrees with our mental health and best agrees with our experiences is key. We also have a couple of other comments here. Being able to handle large amounts of sensitive data collected from users. Again, directly on point, this is one of the key points on security, safety, and privacy of AI systems. We have the way it would impact or target certain groups, lack of diversity in the people who work with AI, et cetera. So yes, I think this is all excellent. The reason why is because we have these peoples who are creating these technologies. They may not have the right perspective when they're defining these. So how do we get, again, our experiences into that and make sure that this technology is not adversely impacting certain populations? And I'm seeing a lot of point on biases as well in terms of looking at this at the entire stage of the pipeline. Again, awesome point here, from the data source to how the questions are being asked. And finally, one point on how it can collect way too much data and how getting that much information about every user is not necessarily healthy. And that's that point back to big data. So thank you so much, everyone. I think that's an awesome characterization of the different principles I wanted to talk about related to AI ethics. And this is covering almost all of the different points that you mentioned here. So here, and it's actually not addressing some of them. So we're going to talk about that as well, because there are a couple of disadvantages to looking at this just from one narrow lens. So what is AI ethics in terms of a solution perspective? I just put this diagram there. It can be kind of confusing to look at first. There is an excellent review paper by the Alan Turing Institute that actually dives into individually each of these. So I'm going to attempt to do that here. And again, just take it as a high level description. We'll be going into individual principles in a few minutes. But first, what do we really care about in terms of responsible innovation? And responsible innovation and ethical innovation, I'm considering these to be the same here. So I really love how the Alan Turing Institute researchers have defined this in terms of 4 primary values: respect, connect, care, and protect. And here really what we're thinking about is being able to respect different populations, have a moral scope for the ethical and societal impacts of the project, and being able to also embody the values of caring about the users that you're impacting and protecting them. And all of these are kind of lending itself to making a deep connection with the user, which we need because, again, the users are the ones who are leveraging the technology. They're being impacted by it. But these are the values. Now, how do we embody this in principles? How do we translate this into practice? So here, there are 4 principles as part of AI ethics that are crucial and are already reflected as part of all of the points that you've mentioned. Fairness, which is tying back to bias, accountability, sustainability, and transparency. And with that, I'm going to actually ignore the process-based governance framework here because that's actually a very in-depth dive into the way we now apply these values and these principles to look at our AI models and figure out, okay, what do I do now that I've designed a system? But I wanted to provide really good emphasis on that second point in terms of the principles here. So let's dive in. First, what do I mean by these individual ones? I just kind of mentioned the names like that. So with AI ethics vectors, what we're looking at is the following. Transparency plus accountability is the right to understand the how and why behind AI decision-making throughout the development and deployment of the system. What do I mean by that? As one of the audience members noted awesomely, one of the key things that we really care about here is AI's inputs in addition to its outputs. So the questions we're asking, the data that's being provided as input, all of this needs to take into account all of these vectors. And so development is really about the design of the AI system. You're writing the code, you're tuning it, you're running it, etc. Deployment is when you're handing your AI model to your user or your customer and you're saying, okay, go ahead and use it, come back to me if you've got any problems, or, maybe, I'll be making improvements to the model as you go along, but I'm really just putting it out there and saying it's ready to use. That's where we want to see transparency and accountability happen at both stages of that. Not only when I've got the AI code in my hand and I'm literally shaping it, but also when it's outside of my hands and in someone else's hands who's going to be impacted by the technology. They need to understand what's going on with AI and why it's making decisions. Next, sustainability. This is going back to the environmental considerations of AI systems. Low resource implementation of AI algorithms is critical. And what do I mean by Internet of Things? It's pretty much exactly what we were talking about in terms of you've got your phone, laptop, any device that's connected to the internet and that is sending information, receiving information. That's kind of the Internet of Things. It's devices that are connected to the internet. And with fairness now, this is really about mitigating and preventing data sets and methodologies that allow AI to reflect manipulative power dynamics. Finally, what I was really surprised to see here as well was the mention of security as part of the chat. This is critical, something that a lot of people don't think about, but I think it's starting to become something that's very important in terms of, privacy and safety considerations, where we've got ethical review and also enforcement of AI ethics, which is critical. We really need to act and make sure that people are not abusing the system of end-to-end AI safety and privacy in the cloud and at the edge. So I have to define 2 terminologies here. What do I mean when I say end-to-end? It's again back to that point. You're really caring about the input data, what's going on inside the AI algorithm, and the outputs, the questions that we're asking, the way that it's going to be put in the hands of the users. All of that needs to take place with a lens of security. And what do I mean when I say cloud and the edge? So, if you've seen Google Cloud or Apple Cloud, you may be familiar with this concept. It's basically just a storage location out there. And when we say out there, usually I visualize a cloud, but really it's a server in some location that's being owned by a company or something similar, with like racks of devices where you've got your information stored. And the cool thing with the cloud is that you're able to access that information from a variety of different devices. You're able to pull it from that server at any time, and you're also able to write to that server. So, if you're editing, like, for example, Google Slides presentation, you're able to make your edits. It's stored on your own personal Google Drive account, and then you're pulling it back in. So that's just one example here. There's very similar ones for Apple's iCloud and similar. Now, what do we mean by the edge? The edge is the actual device that is talking to the cloud, and that's like your phone or your laptop or a digital traffic sign or a self-driving car. So a lot of the devices that are really directly at the end of the system that are talking to the cloud, but are really working and acting based off of the data that they're learning. Okay, and with that, I wanted to now dive into what do we do about this? So I mentioned transparency is something that's critical to me because you need to understand why the AI algorithm is making something. So now we're going to kind of dive into the technical details of what do we look at when we're looking at transparency. And I think that these skills are super valuable to learn early on if you're wanting to go into the AI or data science space, because not only from an AI ethics perspective, but just from a developer perspective, when you're building your AI models, you want to know what assumptions they're making and what they're doing. And that same perspective mirrors over to AI ethics, but it has a lot more weight. So firstly, I want to direct your attention to the left of the slide, where we've got a cute image of a dog and a cat. And here, I'm just going to keep it at that level. I'm not even doing the detailed description. But as part of this, one of the key interesting ways that we've seen of making an AI model explain its decision is the following. If I'm giving it an image, I just want to know which part of the image it's using to make a prediction. So, going back to that horses and unicorn image, if I'm giving it a horse and a unicorn and it's predicting the unicorn as a horse, then I want to be able to figure out, okay, what exactly did you do in order to make that wrong prediction? And again, prediction is really just saying horse, unicorn, plane, cat, dog, human in our example. So in this case, let's look at the left images. So here, when the model is making the prediction cat, we can see that it started to highlight the image around the cat, and it's really using the tail or the bottom half of the cat in order to make the prediction. Now, when the AI algorithm is making the prediction dog, it's really focusing on the face of the dog instead. So now when we start to make predictions that are incorrect, or when the AI algorithm is starting to make predictions that are incorrect, we can start to pinpoint that and say, okay, this is the exact area of the image that it's using to make this incorrect prediction. Now, of course, the next question that'll come up is, okay, then what next? We know which part of the image the AI algorithm is using to make a decision. Now, how do we fix it? What if it's focused on the wrong part of the image? It's a great question. I have not seen a solution for that yet. It seems so obvious because we would want now a solution to be able to say, okay, maybe if it's focusing here on the bottom half of the cat, maybe we needed to focus on the tail or on the ears in order to make the AI algorithm or the model more confident. But no, it's really hard to be able to get the algorithm to do what you want. So that's why one of the key interesting things with transparency is it tells you what the algorithm is focusing on. It's not so clear what do you do now with this information and how do you improve the model. So a lot of what model developers do is they go back, they try to play around these visualizations and figure out what exact portions of the image are being leveraged here. And with this heat map, it's actually kind of interesting because the red parts are really demonstrating the part that the model is focusing on the most. Whereas as you're going to green, yellow, green, blue, it's kind of that, okay, these parts are kind of to be, but not as important as the dark red. So they're able to play around with that and understand more about the model. Now, what about accountability? And I think this is the critical part for those of you who are interested in developing, machine learning model, going into data science. And this is really about how, as developers, do we make it so that our algorithms are accountable? And what I wanted to introduce to you all, if you haven't seen this already, is this really cool idea of model cards. So this is a one-page documentation about an AI model that has almost everything you need to know about it. Super ambitious, and it's not always sufficient, but it actually does an excellent job of just describing everything. So how cool would it be if you were using Siri or Alexa, or you're in a self-driving car, if you got like this one-page document that's essentially telling you, okay, these are the ways that I'm using your information as that AI algorithm. This is where I might fail, so you can anticipate that and plan ahead. Usually that's not the user's role, but it's always good for us to know when the AI algorithm is going to fail so that we can make sure we avoid those situations. This is really how I act for different populations. I have a tendency to prefer, making classifications or making accurate classifications on white populations compared to others. Now, does that mean that it's okay to just release that algorithm? No, of course not. But it's at least giving you some sort of disclaimer that this is what's wrong with me as an AI agent or an AI algorithm, and this is what you should plan ahead for. And it would be fantastic if we had that in play, because then regulators or even users can use that and say, I really don't want the use of this algorithm as part of my business or as part of this use case, or I'm okay with using this algorithm as you're making continuous improvements to make it better, and I'm able to avoid the situations where it fails. So maybe, for example, with this heat map type of approach I showed at the left of the slide, you're able to figure out that the algorithm is really making bad classifications on folks with darker faces because of the lighting setup of where the camera is. So maybe we can start to make some changes to the lighting and try to figure out, okay, maybe I just figure out how to boost the algorithm's accuracy. I'm making this really simplistic, and this is often not the problem at all with AI algorithms. It's really about the input data here. But I hope this kind of conveys one way in which you could leverage a combination of this ethical documentation, which is giving you information about the failure modes of the system and the images that it was used on, et cetera, in order to at least understand what's going on with this AI model, what's wrong with it, and how do we maybe even fix it. Similarly, we care about the data sets as well. And the data sets are really the inputs to the AI model that we're providing. So what do we do there? It's really hard to give one-page documentation about data because data is huge. Again, it can include all sorts of things, your behaviors, trends, times of the day. If you're seeing a camera and we're thinking about this in Internet of Things type of setup, it's really just reporting frames, images all the time and then storing them in a database somewhere. So how do we describe the data? Where this is really where we talk about, was the data ethically collected? Was it collected with consent? What are the problems with the data? And one of the key things, like a really weird problem with a lot of the data sets is that, the image size, sometimes it's really small and sometimes it's really big, but you'll see a lot of the images are collected at the same size. But we want diversity. Just because an image is or an object is really small in your training data set, or the data you're giving to the AI model so it learns a representation, does that world is going to be small for the AI to look at. Sure, maybe you can code in something and say, okay, I want you to look at the world only in this way. But AI developers really care about generalization. And again, so does the public. We want to be able to adapt to our needs, but also by preserving our basic human rights. And so as part of this, the data sheets approach is just one baby step towards accountability for AI systems, where you're at least providing some documentation about the data that's being used for your model and the models itself. Now, given that, I wanted to talk about fairness next. This is a very important topic. I'm not going to be able to do justice for it during this presentation. And again, I'm a technologist, so I have a problem with techno-solutionism, which is, in other words, just applying technology to every single problem that you see. That is not the approach that we want to take here. We want to, again, make sure that we're also considering the societal part of this as well. So given that, if you can kind of keep that bias of mine in the back of your mind while we're looking at fairness, I do actually want to talk about biases now. So what is bias? Where is it coming as part of the pipeline? And as, again, has been noted as part of the chat and some of these comments, really, why do we care about this, and at what parts of the machine learning pipeline or the tunnel or sandwich or whatever way we'd like to think about it? So if I can direct your attention to the left of the slide, this is a typical machine learning pipeline. And you'll see I'm mentioning Google a lot as part of this because they've done a lot of research on this. I'm definitely not endorsing their approach because they've had a lot of big issues with AI ethics in the past and very recently, but they have good diagrams and also ways of characterizing this that make sense. So with this, we've got our machine learning pipeline and we've got different types of biases. And as part of this, we have a couple of different stages of the pipeline that we're looking at. So we've got collecting data, the labeling of data, in addition to training of the machine learning model, where it's learning that representation using chosen metrics and objectives. We've got models that are then deployed in production, which are, in other words, we're just handing that to our customers or our users. And then we're seeing the users see an effect. That's all often neglected. So I think Google has done a good job here characterizing this and also incorporating this as part of their toolkits. So then we see user behavior informing further data collection, and then we go back to collecting data. So here you can see a bunch of red bubbles around how human bias bias comes into this. It comes during the data collection where you're just gathering data about anything or everything that you need for the use case. It comes when you're labeling the data. It comes in when you're training the system with particular objectives, like for example, gender classification. The amount of bias that needs to go into that in order to make a system solely for classifying gender. There's a lot of human bias around that, a lot of human assumptions that are being made that, okay, this type of information really is valuable for the use case. But the question is it? We need to really question some of these assumptions that are coming out of this, is my opinion. And then we've also got, when we're handling or handing our models to our users, human bias coming into that part as well. And also when users are seeing an effect, because our users can be biased as well. We're really talking about model developers as being the people who need the responsibility to design these models ethically. We're talking about regulators and policymakers having the responsibility. But what about the users? There are some malicious users who want to hack into the technology or use it for wrong purposes. How do we handle that? And how do we handle some biases, even from innocent people that are coming into this pipeline and influencing the algorithm? So with that, I do want to bring us to our next challenge in terms of cognitive biases. So now we're going to take a step back from AI for a moment and start to look at the ways that bias influences our decision making. And again, I apologize, the font on the right part of the image is really small, so I'll provide a link to this separately in the chat. But really, what I wanted to get your thoughts on are the following. I'm going to share this website, which has a really interesting diagram of the different types of biases. And I'd like you to let me know which one of these biases have you actually seen impact your decision making. So I'm going to include this in the chat and then share a quick example of what this looks like. Okay, perfect. So here you can see, for example, a bunch of different biases. One of them is related to the anchoring effect, which is essentially relying too much on the initial piece of information offered when making decisions. And I'm just going to pick on this as well. I've definitely seen this bias influence my decision making a lot of times. And in this case, the example given here is that, okay, we already figured out something. Do we really need to go further on it and learn more about it? And really, we make this assumption sometimes when learning, when you're like, okay, I've made a lot, I've learned this topic. I really think that, I read the Wikipedia article, I think I'm an expert on it, and now I'm going to just go forward and make some decisions. But really needing to do more research, taking the time to go through with it, that's really what is enhancing knowledge, not just, a really quick read of a particular article. So I wanted to get your thoughts. Which one of these biases do you think has impacted your decision making? And feel free to pick the one that interests you the most or you've seen has influenced you the most and put it in the chat, please. I'm going to give about one more minute here and then wrap up quickly because I know I'm out of time here. But meanwhile, while we're looking at that, okay, so blind spot bias, that's a very interesting one here. Definitely bandwagon and courtesy biases. So I'm going to actually pull apart one of these here. So in this case, when we've got bandwagon bias, we're seeing that uptake of beliefs and ideas increases the more that they have been already adopted by others. And this is also related to peer pressure and similar. So very interesting to see these and the effect that they have on us. I'm actually going to wrap up really quickly on the remaining part of the presentation. And I apologize for going over time. So here, let's kind of skip over to the last part. I'm just going to take 2 more minutes to summarize here. So now that we've seen these biases and the way that they impact systems, we also really want to think about security and privacy, which is, okay, we've got these biases, they're impacting us. But now when we're starting to collect these data points, how would bias intersect with the privacy of the system? And with this, we have these examples where, for example, machine learning algorithms really can be tricked. They've got their own biases and assumptions that they're making, just similar to ours. I want to direct your attention to the right of this slide. And for example, see this image of a panda, which we can tell is obviously a panda. And now some noise was added to this image. And noise is essentially just a bunch of distorted pixels. And then it resulted in the image at like the far right, which we can still see as a panda, but now the algorithm classifies as a gibbon. So machine learning models have their own assumptions in place, and this is why it's so interesting to see how they can be tricked so quickly. And we really want to understand, well, why is it making that decision? And that's going back to transparency. So with that, I'm going to skip over to some actions we can take. So now we've talked about a couple of different principles. I zoomed by sustainability, but please, if you're interested, feel free to review the slides offline because a couple of interesting statistics there as well. But what are the actions we can take? So as coders, we can practice responsible development of software and AI. And I provided some toolkits here that you can look into as you're continuing to build some AI models and explore the space. As users, we can educate ourselves and contribute to impactful projects and policy. There are lots of different venues for us to do this, newsletters, podcasts, communities, and even these big research institutes that are providing some publications. We've also got ways to contribute where there are these standards consortiums and these organizations that are soliciting feedback from the public. So you don't have to worry about your title or your experience. Your inputs are valuable because you're, again, users who are being impacted by this technology. And I provided a couple of links here that I started out with to start exploring AI ethics and contribute to the space as well. Finally, as advocates, we can call out an advocate against unfair uses of AI. And I provided a link here to a very interesting database created by the Partnership on AI on artificial intelligence incidents. So here we were just talking about this technologically, like, okay, we add some noise to an image and now it's saying it's a gibbon. What were real life use cases where AI has actually failed when it comes to ethics, and the people behind it who have developed the technology have failed? And really being able to call out these solutions and advocate against unfair, biased, unfair, unsecure uses of AI is critical. And I'm going to leave you with those points and say thank you for the time. And again, apologies for running over. I got too excited.
Thank you so much, Ria, for the amazing workshop. I learned so much here today.
Thank you. Much appreciated.
And now I'm just going to share the workshop confirmation link. You can fill it in, please.
And thank you so much for your time all. And please feel free to connect with me via Discord for any follow-up questions. Super happy to answer those.
All right, guys, remember to turn in this Google form to mark your faction so then you can get points for your faction, which would add up to the grand prize of a swag pack or sticker pack that will get directly mailed to you. So make sure to turn that in that form as soon as you can. And also please pass along your thanks to Ria. She came out here for us today and it was a very fun workshop. So yeah, just thank her whenever you can. She's also at the Discord. So if you have any follow-up questions, be sure to just DM her or ask in the panel, in the speakers channel. Sorry, yeah.
Thank you.
And next up in 5 minutes is our Women in Tech panel. So be sure to stay for that.